Alright, good evening everyone. So hope everyone had a good day today.
Wait for it to say like we're informing, notifying. Once got people, then there will be numbers here.
Okay, good evening everyone. So welcome back to our second week DMD and solutions go through. Right, hi everyone. Yeah, I hope everyone had a good day today. Let's say we have around 12 people right now. Okay, so we still have 2 more minutes. 2 more minutes before we begin. Alright, so I'll introduce myself again later at around 8 p.m. Alright. Why not girl? What do you mean why? Well, I don't. What? Alright. I'm. That question is really awkward, honestly. But okay. Bye. I guess. Alright. So let's see. We have around 21 people. Alright, around 21 people who are still here. Alright, thanks for coming over. So like what I mentioned to everyone over here, we are talking about the second week of our DMD. So I hope everyone has tried out the questions. The questions are not are a little bit tough. But I think the front ones should be doable based on our week 1 DMD. Alright, for those who have not done our DMD week 1, make sure to go back. Alright, go to our WhatsApp group over there and then collect the paper and afterwards give it a try. Okay, so 8 p.m. Right, let us begin. Alright, I see everyone over here. Alright, thanks for joining. Teacher Chiu over here. So just to introduce myself, my name is Teacher Chiu from Tech Academy. So graduated from NUS and I have roughly 6 years of teacher experience in mathematics from basically across the board, right? From PSLE, O levels, all the way to A levels as well. Yeah, so I'm currently teaching the primary 5 Math Olympiad classes, so make sure to inquire and contact our marketing team who is in charge of this account if you need more details. Alright, so let's begin on our DMD week 2 now over here. So we can split the following partial fractions as such. Alright, so remember this really nice property over here. 1 over n times n plus 1 is equal to 1 over n minus 1 over n plus 1. No, it's not P5 Math Olympiad, but rather this one is RIPMWC DMD, alright? Wow, I've seen quite a lot of people over here today. Alright, so in this case over here, remember how do we actually show this that time? It's actually pretty straightforward, right? So this one over here, we can actually rewrite this as 1 plus n minus n over n times n plus 1. And then we'll split up this fraction over here. Right, we'll obtain 1 plus n over n times n plus 1 minus n over n times n plus 1. Right, cancelling things out over here nicely. Alright, we have quite a few things that you can cancel out over here. We'll just obtain 1 over n minus 1 over n plus 1. Yeah, so this trick over here has always been, it's actually very useful, alright? Even though partial fractions are taught in Sec 3. But this trick over here is actually very useful, be whatever level you are at. Alright, because you will always try to split fractions up in higher level mathematics. Now, let's begin on the first one over here. Let's look at question 1 right now. So we have 1 over 2 times 3 plus 1 over 3 times 4 equal to some fraction over here. Well, we can apply this nice little property over here, right? So in this case over here for 1, we can really split them up. Into 1/2 minus 1/3 plus 1/3 minus 1/4. Right, remember this was the property over here, right? So this one is actually equal to 1 over 2 times 3. And this one is equal to 1 over 3 times 4. Right? So remember, we are following this. Right? Now, what's next? Okay, we have a minus 1/3 over here. We have a plus 1/3 over here. So it kind of cancels out and becomes 0, right? So in this case over here, what are we going to end off with? We are just really going to end off with half minus 1/4. And this one will just be equal to 1/4, alright? I shall not really talk a bit too much about making the denominator common over here, alright? Okay, so I hope everyone can understand this one over here. Let's move on to number 2. Alright, number 2. So we have this very long expression over here this time around. 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 all the way to 1 over 7 times 8. Now it looks a little bit complicated because now this time around we have a little bit of dots over here. But don't worry, the same method applies. Alright, but how do we write it in a more compact way? I'll show you guys the A-level way of writing, alright? Yeah, so the A-level way of writing is this. So in this case over here, we can write this particular sum as 1 times 2 is equal to 1 minus 1 half. 1 over 2 times 3 is equal to half minus 1/3. Alright, you write the first 3 out. 1 over 3 times 4 is equal to 1/3 minus 1/4. Alright, then afterwards, you can just write your dot dot dot. Then you write down the last 2 terms. So you are expecting a few terms over here, right? You'll be expecting 1 over 6 times 7. Alright, which is equal to 1 over 6 minus 1 over 7. And 1 over 7 times 8, which is equal to 1 over 7 minus 1 over 8. Alright, so we are finding a sum of this. So essentially we are adding up all these guys over here, right? We are adding up all these guys over here. So we need to find a sum. How do we find the sum over here? Well, you see actually the pattern is very nice. Look at the way that I cancel things out. The first one that will cancel out will be the half and minus half. Because I'm adding them out, right? There's a minus half and a plus half. Oh, next one. 1/3 and minus 1/3. So as you can expect over here, right? You can see that a lot of things will get cancelled out. Alright, all the way to plus 1 over 7 minus 1 over 7. So what are we left with? We are just left with 2 terms, right? We are just left with 1 over here and minus 1 over 8 over here. So I'm pretty much left with 1 minus 1 over 8, in which we'll obtain 7 over 8 as our final answer. Alright, so I hope this question is easy enough for everyone. Anyone has any questions so far? Alright, just feel free to write in the chat, alright? So afterwards I can see everyone. Alright, anyone has any questions? No, right? Let me move on, alright? Let's see a real application of this kind of questions. Alright, so what about second question? We need to evaluate this little complicated expression. Not really complicated, but probably tedious if you do not know the trick. Now, look at this carefully. Now, I always do my best to remember this particular pattern. Right? This 2, 6, 12, 20 pattern is extremely important. Alright, yeah, the lesson is from 8 to 9, roughly 9, alright? So this 2, 6, 12, and 20 is an extremely important pattern to keep in mind about, especially for RIPMWC. Why? Because 2, 6, 12, 20 can be rewritten as 1 times 2, 2 times 3, 3 times 4, and 4 times 5. Alright, very, very important, very, very powerful. Alright, so you guys see these numbers over here, right? Always make sure to split them out into this way. Alright, so we are going to rewrite this expression first. Alright, write it as 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5. Okay, what's next? Alright, what's next? So this one is for students who are preparing for our dear RIPMWC, alright? So generally the upper primary level. So now we remember our little formula that we had just now, right? Let me write it on the side over here. We have that little nice formula over there. 1 over n times n plus 1 is equal to 1 over n minus 1 over n plus 1, right? So we are going to apply this nice formula over here. Now, how are we going to apply this? We are going to split them up as usual. This one will just be equal to 1 minus half, right, plus half minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5. And then you see, right, there's more cancellations, right? You can see that there's a lot of cancellations over here, right? Minus half plus half disappear. Minus 1/3 plus 1/3 also disappear. Minus 1/4 plus 1/4 also disappear. We are left with 1 minus 1 out of 5, right? Which is really straightforward. You are just pretty much ending up with this. And you get final answer of 4/5. Yep, the telescopic series, yeah. So this one is called method of difference. So some of you guys probably know that this is the telescoping series, which is formally taught in JC. And the way to solve this kind, in fact, a closed form formula for this is to use the method of difference. Yep. Okay, everyone's okay so far? I hope everyone's good. Yeah, I mean can I can go toilet but then afterwards I'll still continue lah. Alright, can let me move on Okay. Now this one over here we have calculate the following a little bit messy expression over here. We have half multiplied by 2023 times 2022 minus 2021 minus 2022 times 2021. Right, we have a very long looking expression over here. Now, one very important thing, right, is to always keep in mind about the concept of factorization, right? Even though factorization is only properly taught in Sec 1, it is extremely important to learn it when you are preparing for RIPMWC. Now, what does factorization really mean, right? This one really just means sum to product. Alright, so the simple form is this, alright, when we have ax plus ay, the Sec 1 form, right, I think some of you guys who are Sec 1 students should know how to factorize this. This one would really be equal to ax plus y. That's the concept over here that we need to utilize. Now, you look at this very complicated looking expression over here. There are some things that are common, we can't remove them, right? You look at it carefully. We can start by looking for some patterns, right? We can look for 2023 multiplied by 2022 minus 2022 times 2021. What's common between both of them? It's 2022 and 2022. And then using our factorization property over here, right? We can actually pull them out, right? And then what are we left with? We are left with 2023 minus 2021. And then what's next? 2023 minus 2021 is just going to be equal to 2. Right, so we're just going to leave it over here, right? 2022 times 2. That's it. So we have kind of simplified the expression a little bit. Let's see if we have this particular pattern that's going on. Alright, let's continue. So we have the next two terms over here. Alright, so these are the first two that I used just now. I'm going to move on to this one now. Right, so at this 2021, right, it's going to be a little bit tight. 20 minus 2020 times 2019. As usual, what's common? The 2020 is actually very common over here right now, right? So we are going to pull it out. 2020, 2021 minus 2019, which is equal to 2020 times 2. Again, we see a pattern that's going on over here, right? We see a very, very nice pattern. But does it work all the way? So we can check this one. Alright, this one is going to be 3 times 2 minus 2 times 1. I think everyone can evaluate this one. This one is just going to be 2. 3 minus 1. This is just 2 times 2. Right, so in this case over here, we notice some sort of pattern. Right, we notice some sort of pattern that's going on over here. We seem to actually get this particular expression. The expression, rewriting. Alright, we are going to obtain half Alright, 2, 0, 2, 2 times 2 plus 2, 0, 2, 0 times 2 plus all the way to 2 times 2. Okay, so somewhere along these lines over here. Now, but we remember we have actually a lot of 2's over here, right? And remember this half actually applies for everyone in the sense that we can expand them, right? There's a little bit of expansion. So this one, when we move here, this one is expansion. And then if we move backwards, this one is factorization. Right? If we were to expand them, we need to apply the rainbow method, alright? So all the way. But we know that 2 times half is just going to be 1, right? 2 times half is just going to be 1. So we are just going to end off with 2022 plus 2020 plus all the way to 2. Okay, so at this point in time, right? At this point in time, there are a few methods to work out on this question. There are a few methods to solve this question. We are going to use the very standard formula of we are going to use the very standard formula over here. AP, very standard AP formula. 1 plus 2 plus 3 all the way to plus n is equal to n multiplied by n plus 1 over 2. We are going to use this formula. Alright, how are we going to use this formula? Well, you notice one very important thing. All these guys over here are multiples of 2. So we can actually factorize out 2 from each of them. 2, 1, 0, 1, 1 plus 1, 0, 1, 0 plus all the way to 1. So you notice that this and this is pretty much the same, except that n is equal to 1, 0, 1, 1 over here. Now, what we going to end off with? We are going to end off with 2 multiplied by 1011 times 1012 over 2. And just nice, the 2 cancels out. So the formula over here can actually be simplified into just 1011 times 1012. And guess what we are going to get for our final answer? We are going to get a little nice number over here. So after doing your long multiplication, you are going to end up with 102, 31, 32. Right? And of course, in this case, your answer will be B. Alright, I hope everyone can understand what is going on over here. Alright, anyone has any questions? Anyone? No? Yes? No, alright. So, yeah, it's a little bit tough. Alright, so, yeah, maybe halfway. Alright, maybe we are kind of halfway there right now. So, if there anyone with any questions, right, do let me know. So, once again, for those who came a little bit late, I'll reintroduce myself. My name is Teacher Chiu. I'm currently a teacher at Ting Academy. I have roughly 6 years of teacher experience in our PSL mathematics, O-level mathematics, and A-level mathematics. So feel free to contact the marketing team over here if you would like to inquire more about our RIPMWC short-term courses, alright, and our P5MO courses, alright. Yeah, currently teaching the primary 5 Math Olympiad courses and the RIPMWC short-term course that is coming up next week. Alright, and so anyone else has any questions for me? Alright, if not, I'll move on already, Alright, let's move on then. Okay, question 4. Alright, a little bit complicated over here. Alright, my apologies. I would like to talk a little bit about the error over here. So there should be a 58 plus 58 over 60 over here. Alright, based on the particular pattern that we actually have. Alright, so we have half plus 1/3 plus all the way to 1 out of 60. 2 over 3 plus 2 over 4 all the way to 2 out of 60. 3 over 4, 3 over 5 all the way to 3 out of 60. So naturally, you guys think about it, there should be a 58 out of 59 plus 58 out of 60 before we end off a 59 out of 60. So there's a little bit of error over here, alright? So make sure to keep in mind, alright? Alright, add this term. Alright, very important. Alright, so how are we going to solve this question? Alright, so doesn't seem like there's a lot of pattern that's going on over here. It seems a little bit messy. But what we learn about fractions is that we can add fractions together when the denominators are equal. So we kind of want to lean towards that concept. Alright, so let's rearrange and try to collect some terms together. Alright, so so we'll look at denominators, alright? Alright, and look at the terms. Alright, so we'll look at denominators and we'll look at the terms over here. So let's take a look at denominators that start with 2. Alright, where are the terms with denominator 2? Well, notice that there's only just half over here, right? So there's only one term. Alright, what about 3? Alright, you can see that this one there is 1/3 and a 2/3. So there's a half and 2/3. What about 4? Alright, so I believe some of you guys can see there's a 1/4 over here. There's a 2/4 over here. There's 3/4 over here as well. Right, so we have 1/4, 2/4, 3/4. I believe everyone is seeing the pattern right now. I hope everyone can kind of see that there's some sort of a pattern that's going on over here. Right, now in this case over here, I'm going to move on to 5, alright, to make it a little bit more pronounced. Right, what about 5? 5, we actually have 1/5, 2/5, 3/5, 4/5. Right, that is the crucial idea that I want to bring around about. We can add up fractions with like denominators. So we are right now grouping them together first. So in this case, we'll move on all the way down to 60. So for 60, you are expecting 1 out of 60, 2 out of 60, 3 out of 60, all the way to 59 out of 60. Alright, we have seen this pattern over here, and we are going to find the sum of it. Alright, so how are we going to find a sum? We are going to have another nice column over here called sum. Okay, so naturally half is just going to be half. Alright, what about this one? 1/3 and 2/3. 1/3 and 2/3. Well, 1/3 and 2/3 is just going to be 1, alright? We can write that down as 1. Alright, what about this? 1, 2, 3, divided by 4, all of them. Well, we can use our formula, right? Now, in this case over here, this one will just really be 1 plus 2 plus 3 over 4. But we know that that's 6/4, right? Maybe you can write it down, 6/4. Alright, what would this actually be? This one is actually just, when we simplify, it's going to be 3/2. Okay, what about this one? 1, 2, 3, 4 over 5. Well, it gets a little bit longer and longer, right? So we need to apply what we had learned just now. The very nice quickie formula. 4 times 5 over 2 divided by 5. Then you realize this is just going to be 2. So all the way down to this one is just going to be 1 plus 2 plus all the way to plus 59 over 60. Right, and this one is just going to be equal to 59 times 60 over 2 divided by 60. And we are going to end up with 59 over 2. So what's the sum? Well, we have half, 1, 3/2, 2. You guys notice something, it ends up at 59/2. You guys notice that, right? In this case over here, there's kind of an AP that's going on. There's kind of an arithmetic progression that's going on over here. Alright, but no worries. We can actually do a little bit of factorization and we'll notice that there's a little bit of trick that's involved. Now, so the sum will just really be half plus 2/2. This one is 1, alright? Be really careful. 1. This is from here. Plus 3/2. Right, which is over here. What How about 2? 2 is going to be 4 over 2. Alright, this is the 2. You guys can see a pattern that's going on. All the way to 59 over 2. Right, there's a very, very, very nice pattern that's going on over here. And how are we going to solve this? Well, we can factorize out the half, right? Half. Alright, we're going to end up with 1 plus 2 plus 3 plus 4 all the way to plus 59. Then seems like... Alright, I hope everyone can see it. Alright, is it a little bit better? Alright, yeah, due to a lack of space, alright, due to a little bit of space constraint, alright, I'm going to remove the sum area. I'm just going to write it over there, alright? Yeah, I think this one is the more important part, alright? Alright, so after that, what's next? Alright, this one is just going to be equal to half multiplied by 59 times 60 over 2. So you guys notice we can do a little bit of cancelling. Alright, so what level math is this? This one is actually the RIPMWC math. Alright, yeah, so RIPMWC math over here. So you are looking at upper primary. Alright, yeah, sorry, we don't teach general paper over here. Yeah, this one is more of a math education center. My apologies. Alright, yeah, general paper is a little bit too tough as well, right? Right, you need all sorts of examples. Alright, yeah, so over here we can do a little bit of cancellation. If you think about it, this 2 can be cancelled to get 30 to simplify things. Or AB, GP, alright, GP is not tested. Yeah, GP, I know where you're getting at, but GP generally we don't really see, and in fact I had never once saw a GP question in the competitions over here. I mean, because first off, the formula is very complicated. You have a 1 minus r power n divided by 1 minus r, and then you also have the convergence to infinity, so a over 1 minus r. So you wouldn't really be expecting upper primary school students to be able to do this. Alright, yeah, so we can cancel this, 15. Alright, we're going to obtain 59 times 15, alright, which simplifies a lot of things, alright, and you're going to end up with 885. Alright, so most importantly, right, is that you do not blindly multiply the 59 and 60 together and then divide by 4. But rather, you cancel out the 60 and the 2 first, you get a 30. Then the 30 you cancel again with the 2, you get a 15. Then you simplify a lot. You just need to do 59 times 15 instead. Alright, if you want to do this, right, in fact, I have a trick, alright, for 59s. It's just going to be 60 times 15 minus away 15, right? Yeah, so 60 times 15 is probably going to be a little bit easier. Alright, so that's the whole idea. Alright, so anyone has any questions so far? Alright, so majority of these are actually AP, they fall under the concept arithmetic progression. They are only actually taught formally in JC1 level. Yeah, so majority of the times is for students who are preparing for A levels, yeah, this kind of things. And we are actually testing it for IPMWC, unfortunately. Alright, so yep. May I move on, everyone? Okay, so I can move on already, Alright, let me move on. Alright, I hope there's no one. I got 15. Alright, so I'll repeat myself over here, alright? So I'll repeat this, alright? Half 2, right? So remember, fractions can cancel out, right? We have things like cancelling over here. The 2 and the 60 can actually cancel off. Because 60 divided by 2, we are going to end up with 30. So at the end, you are just going to get 59 times 30 divided by 2. But then afterwards, right, this 30, right, divided by 2, right, we are going to get 15. So you can cancel it again. 15. So I just going to end up with 59 times 15. Right, so cancelling is a very important skill because you simplify a lot of things over here, which is extremely important because you are not allowed to use calculators. Alright, so by simplifying this, right, you do not have to do the tedious work of 59 times 60 divided by 4. Instead, you just need to do 59 times 15. Alright, everyone can catch? Alright, everyone can catch, right? Let me move on already, yeah? Hey, anyone else has any questions that they would like to ask me? Hey, yes, no, I don't know. Alright, so let me move on, alright? Let me move on. Alright, so another method of difference question. Okay, so let's take a look at this. Calculate the expression below, rounded to the nearest whole number. Alright, in this case over here, we'll find the exact form first. Alright, we'll find the exact form first, and then afterwards we'll round it off. How are we going to do this? It looks a little bit complicated. In this case over here, let's take a look closely. Well, 1 square plus 1 plus 1 again, divided by 1 times 2. And then we have 2 square plus 2 plus 1 divided by 2 times 3. 3 square plus 3 plus 1 divided by 3 times 4. All the way down to 2012 square plus 2012 plus 1 divided by 2012 times 2013. Right, it looks a little complicated. But tell you what, how about looking for the general term first, alright? Look out for a general term first. Nth term. Alright, so what is going to be the nth term over here? Well, you guys notice there are quite a few things that are moving over here. The ones are moving, the 1 squareds are moving. So definitely you expect the nth term to be n squared. And this one, 1, 2, 3, right, is going to move as well. So you are going to be expecting an n. The 1 stays constant over here, so it's not going to move, it's not going to change. The 1, 2, alright, you will look at this carefully, 1, 2, 3, alright. So in this case over here, we are expecting an n as well. But what about this 2, 3, 4? Right, for the first term, this is a 2. For the second term, this is a 3. For the third term, this is a 4. So for the nth term, you are expecting a n plus 1. Alright, so with all this really nice information over here, we can actually look out for the general nth term. It's going to be n squared, because 1, 2, 3, 4, all the way to n. 1, 2, 3. Now this one is going to be just n. And then we have a plus 1, alright? Then divided by, this is 1, 2, 3 again, alright, it's going to be n. And multiplied by n plus 1, because first term is 2, second term is 3, third term is 4. Nth term, you are expecting n plus 1. Wow. Okay, so we are finding a sum, alright? So some of you guys, right, might have seen these kind of things before, alright? The sum itself, or some of you guys who might be a little bit more advanced, you are actually looking for this, alright? This one is going to end off at 2012. Yeah, so some of you guys might know about this, but we do not need to really use this, alright? We do not really need to use this. Now, in this case over here, how are we going to simplify this? Well, looks a little bit complex, looks a little bit complicated, but tell you what, I can actually factorize out the n at the top. Right, so we are seeing something over here. I factorized out an n at the top. And what's next? Well, in this case over here, I can consider splitting up the fraction into 2 pieces. How do I split them up? I split them out in this fashion. So I can split out on this portion over here. And you guys notice n multiplied by n plus 1 divided by n multiplied by n plus 1. This is just really going to be 1, right? This one is just really going to be 1. And then we're going to end off with n multiplied by n plus 1. Hey, this looks very familiar, right? This looks very, very familiar over here. Right, we had learned it just now. We learned it at the start of our class. Well, in this case, we know how to split it. I'm pretty sure everyone knows how to split it. is just going to be 1 over n minus 1 over n plus 1. Alright, so I actually taught this just now, so it's very nice over here where you can actually split this up into this particular partial fraction over here. Alright, so that's the whole concept behind this. We actually took a very complicated expression and we simplified it and broke it out into this. So let's take a look, how are we going to apply this to our little formulas over here now. Now, when you think about it over here, right, we have this nice formula. Alright, we are going to calculate the sum now. Alright, so n starts from 1. Alright, this is the start. All the way to n equal to 2012 at the end. So you need to find the sum over here. So let's do it up. So we have n equal 1. Alright, we have the 1 square plus 1 over 1 times 2 is going to be equal to 1 plus 1 over 1 minus 1 over 2. Based on our formula over here. Oh, n equal to 2 square plus 2 plus 1 over 2 times 3. This is going to be 1 plus 1 half minus 1 over 3. You guys can see a pattern that's going on over here already, alright? So maybe I'll do one more. N equal to 3. 3 squared plus 3 plus 1 over 3 times 4. 1 plus 1/3 minus 1/4. Right, afterwards we can do all the way our dots down all the way to n equal to 2012. Alright, this one is just going to be 2012 squared plus 2012 plus 1 over 2012 times 2013. 1 plus 1 over 2012 minus 1 over 2013 is our formula. Then you guys can see got some cancellation, right? That's quite nice. Alright, there's some nice cancellation over here. We can do our cancelling again. Alright, so the diagonal style of cancelling comes back. Yep. The original problem is reduced to a telescoping sum. Yep. So this method is called a method of difference. Yeah, in fact, this one is actually a telescoping series, right? But you need to apply partial fractions over here first in order to see the pattern, alright? Just like in a lot of common A-level questions. I mean, this one technically can be an A-level question, which is pretty much worth like 3 marks. Yeah, so we are going to apply this standard A-level method of doing this. Alright, we're going to find the sum now. Now in this case over here, we have 1, 1. Now notice that we have a lot of 1s to deal with. But how many 1s are there in total? There's actually a total of 2012 ones because following this by pattern. 1, 2, 3, all the way to 2012. So there's 2012 ones, which will form 2012. And then we have 1 over here. Be very careful, there's actually a 1 over here. So you need plus 1. And minus 1 over 2013. Right, so after simplifying, we are going to obtain, alright, we'll shift it a little bit there, alright. We're going to obtain 2012 over 2013. And we are going to round this off to the nearest whole number. We are going to get 2013 as our final answer. Right, that is the whole idea. Alright, this one is actually a very challenging question, especially for primary school students, because we are actually using quite a bit of secondary school and JC concepts. Alright, partial fractions, they are only taught in A-math when a kid reaches Sec 3, and method of difference is only properly taught in J1. Alright, so something to keep in mind about. Alright, remember this very important and neat trick over here, the partial fractions trick. Alright, plus n minus n. Alright, so I hope everyone can at least take away this portion from this little DMD over here that I have for everyone. Alright, so let me move on to the next one, alright? Let me move on to the next question, alright? Is everyone alright so far? I hope it's not too hard. Alright, good. So, if no one has any questions, alright, let me move on to the next one. Alright, so this time around we have a story question. Right, this time around we have a story question. So let's take a look. Right, David and Emma are working as a pair to complete a math journal. Yeah, working alone, where David and Emma, each of them will need 10 days and 18 days respectively to complete the journal. In fact, David started to work alone for some days and then handed the work over to Emma. The journal was completed in 14 days altogether. How many days did Emma work on the journal? Well, so in this case over here, right, you guys think a little bit about it, right? If David works alone, alright, if David works alone, let's think about it. Alright, David works alone. Let's imagine if David works alone. So, in order to get this, alright, one journal will be equal to 10 days for David. So now you need to ask yourself, if David works alone, one journal is equal to 10 days. What about 1 day? 1 day is just going to be 1 over 10 of a journal, right? So it's going to be 1 over 10 of a journal. Right? I'm pretty sure this, I don't think this is going to be on your FYP. if it's going to be on your FYP, something is a little bit wrong, right? Yeah. Alright, so let's move on, right? The next one. What about Emma? Alright, let's take a look at Emma. Alright. Alright, Emma working alone. Alright, sorry, can someone tell me what is FYP? Like the long form of it instead of acronym. So that because I'm a little bit confused. And what does it mean by FYP, alright? Maybe someone can enlighten me a little bit. Oh, for you. Wait, what? Alright, for you, Paige. Alright, that's... Oh, really? Oh. Hi. Sorry about it. Yeah, sorry. Alright, so hi. I hope everyone can enjoy. Oops. Yeah, so if Emma works alone, one journal is equal to 18 days. Alright, algorithms are a little bit, sometimes it goes a little bit haywire nowadays. Yeah. So after that, right, 14 days over here, 18 days over here. So clearly we have 1 over 18. Our journal is done in 1 day. So we are going to let, alright, because we are looking for how many days did Emma work on the journal, we are going to let X represent the number of days Emma worked on the journal. So naturally, she would have worked. How much would she have worked, right? She will have done X over 18 of the journal. We got X days for her. Then what about David? Well, they did 14 days altogether, right? So if Emma worked X days, David is going to work 14 minus X days. Right. So in this case over here, 14 minus X out of 10 of a journal is done in 14 minus X days. But we know that one whole journal is actually completed. We know that one whole journal is actually completed in the in this 14 days over here. So the sum of these two guys must be equal to 1. Right, these two guys must be equal to 1. So I'm going to write it over here in the middle. 14 minus X over 10 plus X over 18 must be equal to 1. Right, one full journal. Right, that's the crucial idea that I want to bring everyone about in this question. Now, how are we going to solve this? Well, you can start by combining fractions first, alright? This one is kind of solving a simple linear equation right now, right? So in this case over here, we can actually combine them together. The common factor, the common denominator this time around, I'm going to put it as 90. Right, so we are going to obtain 126 minus 9x, 90, plus 5x over 90 is equal to 1. Right, minus 9x plus 5x is going to be 4x. So 126 minus 4x over 90 is equal to 1. Cross multiply, alright, remember the cross multiply idea, alright, so 1 over 1. 126 minus 4x equal to 90. 4x is going to be equal to 126 minus 90, which is equal to 36. And so x will just be equal to 9. What is it x over 18 for Emma? You look at our definition over here. We let x represent the number of days Emma worked on the journal. So we can say she worked for x days. Right? If one day she does 1 over 18 of a journal, then in x days, she must have done x over 18 of a journal. Alright, I hope that answers your question. Alright, I hope it's clear. So after that, right, we know that they had done 14 days, right? So David must have worked 14 minus x days. So if one day David does 1 hour 10 of a journal, in 14 minus x days, he must have completed 14 minus x over 10 of a journal. And these two must add up to form one full journal. What about 180? I mean, you can. 180 is going to give you the same equation, alright? But it's just that teacher Chu will usually try and find the LCM over here. Yeah, 180 works as well, alright? In fact, you want to do 360, it also works. Alright, so let me move on to the next portion. Alright, let me move on to the next one. Alright, let's move on to the last question. Alright, anyone has any other questions though? Yeah, before that. Yeah. If anyone has any questions, let me know, alright? Before I move on to the last one. The last one is probably a little bit more difficult. Alright, I'll move on to the last question for a day, before I call it a day. Alright, so this one is going to be tough, alright? It's going to be a little bit tough. Let's take a look at this question now. Patrick started walking at a constant rate along a straight road from school to the park. 1 hour after Patrick left, Tanya started running along the same road from the school to the park. And 1 hour after Tanya left, Jules started bicycling, right? Bicycling. Yeah, bicycling. Wow. Along the same road from the school to the park, right? And Tanya ran at a constant rate of 2 km per hour faster than Patrick walked, and Joe cycled at a constant rate of 7 km faster than Tanya ran. Now, the key thing over here is this. If all three of them, right, arrived at the park at the same time, find the distance between the school and the park. Wow, this is actually a little bit complicated, right? It's actually really long, alright? So, having our DST is going to be very helpful, right? We are going to draw a little pyramid here first. Alright. Distance, speed, time. Right? So, one good thing that we know is that the time is the same for all of them. And we do not really know the distance and speed, other than some little differences over here. So you can consider doing a little bit of variables, but we are going to draw out some preliminaries, alright? Okay, so school to a park, right? We are trying to find the distance, right? We are trying to find distance. Alright, we're going to let the distance be D. Alright, we're going to let the distance be D this time. But what about the speed? Well, we don't really have the speed, right? So we can as usual, let Alright, let the speed of Patrick be x kilometer per hour. Alright, this is this is P6, alright? This is upper primary. So this one is actually we are preparing students for the Raffles Institution primary math world contest. Alright, so basically a math Olympiad contest. Yeah, so these are the type of questions that we're expecting for RIPMWC. Right? Yeah, so a little bit tough. Now we're gonna let the speed of Patrick be x kilometers per hour. Distance be d. What's next? Well, in this case over here, you guys look at it a little bit carefully. Tanya ran at a constant rate of 2 kilometers faster than Patrick walked. So Tanya must be x plus 2 km per hour. Alright, yeah, sec 1. I don't think you can join the competition anymore though. Yeah, but feel free to contact Ting Academy if you require any math support, alright? Okay, so let me move on, alright? Let me move on to the next part, Joe's. Right? Joules is going to be x plus 9 km per hour. Alright, question 6, right? You're looking at question 6. Your question 6 final answer should be 9. Alright, question 6, the final answer is 9, alright? Alright, so Joules is going to be x plus 9 km per hour because he cycled at a constant rate of 7 km per hour faster than Tanya ran. So Tanya runs at x plus 2. So Joules must run at x plus 9. Okay, so what's next? Alright, what's next over here? Looks a little bit complicated. Now, one very important thing is that, you guys think a little bit about it, is that all three of them arrive at the park at the same time. So think about it. The time taken, right? Time taken. Right? Let's take a look at Patrick. Patrick has taken a complete... Patrick has a speed of x kilometers per hour. Distance is d. And then recall our little pyramid over here. Distance, speed, time. So what's the time taken by Patrick? It's going to be d over x. Right? What's next? Right, what about Tanya? Well, think about it. Tanya actually, speed is x plus 2. Distance is d. So, naturally, it's going to be a distance divided by speed thing again. It's going to be d over x plus 2. But wait, there's a little bit of problem over here, right? 1 hour after Patrick left. So, over here, right, Tanya has actually taken 1 more hour before they reach together at the same time. Otherwise, she will actually reach 1 hour earlier than Patrick. Think about it, the speed over here is faster than Patrick. You can't reach at the same time if both their speeds are different and the distance is the same. So that's why over here is a plus 1. That's why Tanya has taken 1 more hour. What about Jose? Jose or Jose? I'm really not sure at this point. Jose himself, in this case, he will have taken d over x plus 9 plus 2 hours. Right? Because 1 hour after Tanya left. So technically speaking, Jose waited for 2 hours. He waited for Patrick to leave, wait for 1 hour, he waited for Tanya to leave, wait for another hour, then he finally leave. And guess what? All 3 timings must be equal. So based on this logic, all 3 timings are equal to each other. Right? Because all 3 of them arrive at the park at the same time. Alright, I hope this one isn't too complicated, but we need to solve a pair of simultaneous equations now. Alright, not necessarily linear over here, right? In fact, it looks a little bit bad right now. So we're going to equate them now. We're going to obtain d over x plus 2 plus 1 equal to d over x. That's the first equation. Alright, we're going to obtain d over x plus 9 plus 2 equal to d over x, which is the second equation. Alright, we're going to employ the method of substitution over here in order to solve for our equations. Alright, so over here, right, by rewriting 1, we can actually obtain 1 equal to d over x minus d over x plus 2, which is equal to 1 d, plot the d over there, obtain 1 over x minus 1 over x plus 2. James, you are expected, you should know how to simplify these kind of equations in Sec 1 by now. You should be roughly at that topic by now. What's next over here? Well, you kind of need to combine them together, right? So we are going to obtain 1 equal to d multiplied by x plus 2 minus x times x plus 2. Right, the two x's will cancel off. And we're going to get 1 equal to d multiplied by 2 over x multiplied by x plus 2. Alright, we're going to make d the subject this time round. Alright, so d is going to be equal to x multiplied by x plus 2 over 2. Right, a little bit complex, but I hope everyone can get this portion. A lot of manipulation. So this one is actually combined fractions. Right, we actually combine fractions based on a denominator. And then afterwards, what I did was actually flip the thing over to the one side. Right, so I shift the bottom, x multiply x plus 2 to the top, and 2 towards the bottom. Right, so I'm going to obtain this, d. Okay, what's next? Right, as the name suggests, the concept is substitution. Right, the concept of substitution over here. We are going to use another piece of paper, alright? So I hope everyone is a little bit ready. Right, we're going to solve for d and x, alright? I'll repeat myself, I'll solve for d and x over here. So let us take a look at the second equation, alright? Rightio. Now this one, we're going to obtain 2 is equal to d over x minus d over x plus 9. Factorize out the d. We'll obtain 1 over x minus 1 over x plus 9. And then combining fractions, we are going to obtain x plus 9 minus x over x multiplied by x plus 9. Which will give us a final answer of 2 equal to d multiplied by 9 over x times x plus 9. Alright, great. So we are pretty close to solving it already. Now, in this case over here, we know one very important thing is that this. We know that d is equal to x times x plus 2 divided by 2. And we have 2 equal to d times 9 over x times x plus 9. So why not we actually put this inside here? Replace it. Obtain 2 is equal to x times x plus 2 over 2 times 9 over x multiplied by x plus 9. Alright, so we can see an x over here and the x over here cancelling off. And afterwards, the 2, we are going to obtain 2 equal to 9 over 2 multiplied by x plus 2 over x plus 9. Well, we can cross multiply this away first. We'll obtain 4 over 9 equal x plus 2 over x plus 9. And this one is going to be a simple fractional equation we need to kind of cross multiply them away first. Right, 4 multiplied by x plus 9 equal to 9 multiplied by x plus 2. And what are we going to obtain? We're going to apply our rainbow method. Now this one is going to get 4x plus 36 equal to 9x plus 18. Now, so in this case, we are going to simplify this a little bit more. 5x equal to 18, and hence x is equal to 18 over 5. But is that it? That's not really it, right? We are looking for the distance, alright? Remember our question. We are looking for the distance. And remember that our distance is actually defined to be d equal x times x plus 2 divided by 2. And we already don't know what's x. So our d distance is going to really just be 18 over 5 multiplied by 18 over 5 plus 2 divided by 2. We are going to obtain 18 over 5 times 28 over 5 divided by 2. Alright, so we can simplify this a little bit. We're going to obtain 18 times 14 over 25. And this is going to give us a final answer of 252 over 25. So the distance between the school and the park is 252 divided by 25 kilometers. Alright, so very complex, alright, a little bit difficult, alright, very difficult, pretty difficult question over here, alright. But I hope everyone can understand what is going on. Alright, so with that, that's pretty much about it for our live stream today. Alright, thanks for coming over, everyone. So as usual, my name is Teacher Chew. I'm from Tech Academy with over 6 years of experience in teaching PSLE, O-level and A-level mathematics. So I'm currently teaching a P5, Primary 5 Math Olympiad courses right now. So if anyone has any inquiries, please feel free to contact the TikTok page over here. Alright, and let me know if you guys have any other comments. So with that, that is pretty much about it for the day. Alright, thanks everyone. Unless anyone has any other questions that they would like to ask. Yes? No? Right? Anyone has any other questions? No? Right? If not, thank you very much. I will see everyone. Oh, there's no differentiation here, right? Yeah, there's no calculus involved in lower primary. Alright, so no worries. Alright? Anyone else has anything that they would like to talk a little bit about? No? Yes? Right? If you guys have any inquiries of any sorts, alright, feel free to contact our TikTok page over here, alright? And one of my colleagues will get back to you guys, alright? So with that, thanks everyone. I will see everyone next week for the next portion of the DMD. Alright, see you guys. Bye-bye. Oh, that's it.